Here we will have a quick revision on chapter 4, quadrilaterals, okay? Very simple. We have two tests already, and many students perform very well. Let's recall what is a kite. What's a kite? It has two properties, okay? The diagonals are perpendicular to each other. This is a right angle, okay? And then this axis makes this triangle and this triangle the same, okay? Congruent. This is property of kite, okay? And then trapezium. Trapezium is just like two opposite lines are parallel to each other. So you have, this is actually interior angles. Interior angles, AD parallels BC, okay? But we can also call it property of trapezium. For example, if you are going to find x and y, you know that these two angles adding up together is 180 degrees, property of trapezium. Therefore, you find out x. Once you find out x, these two angles adding up together is 180 degrees again, property of trapezium. You got y, okay? And for parallelogram, there are a lot of properties. The opposite sides are equal, okay? The opposite sides are equal. And then the opposite angles are equal, okay? And the diagonal bisect each other, okay? This all we can call property of parallelogram instead of this 1, 2, and 3, okay? So we better use property of parallelogram not to get mixed up with them. But for proofs, okay, for proofs, you have to know there are four conditions: either opposite sides equal, or opposite angles equal, or diagonal bisect each other, or one pair of opposite sides equal and parallel. Of course, the definition is opposite sides, both pairs parallel, both opposite sides parallel, okay, which is the definition of a parallelogram. Okay, so for again, I remind you, for proofs you have to state either 1, 2, 3, or 4 or definition, okay? And then we'll see a simple example. First, this is only a quadrilateral. You don't know whether it is a parallelogram or not. It asks you to find out x. You know that all the angles add up together equals to 360 angle sum of polygon. Therefore, you find out x equals to 50 degrees, okay? And part B asks you to prove that it is a parallelogram, okay? So you put the x here, 50 degrees, therefore it is 70 degrees. These two adding up together is 180 degrees. This is parallel, okay? But you see that, oh, you have to prove a lot. So you try to find out all the angles. If this is 50 degrees, this is 110, this is 70 degrees. You see that the opposite sides, the opposite angles are equal, okay? Opposite angles are equal, okay? So you prove that it is a parallelogram. And then find out the value of y. If this is really a parallelogram, these two are equal in length, that is 2y equals to y plus 4, okay? Therefore, you know that y is 4, okay? No need to add cm. And rectangle is a special parallelogram, okay? What else of properties does it have? All the interior angles are 90 degrees. The diagonals, all four diagonals are equal, okay? All this is part D. These all four diagonals are equal, and then the diagonals are equal, okay? And then we see that square is a special rectangle, okay? The four sides are equal in length, okay? And the diagonal are perpendicular to each other, and all the angles between the diagonals and the side are 45 degrees, okay? And then we see this example. You see the solution is very short. So you try to think about it before you do it. Okay, this is a square. And then CDE is a equilateral triangle. So this is 60 degrees. This is 60 degrees. And this is 60 degrees. Okay? You are going to find angle GDF, this angle. Okay? But you know that this is the diagonal. This is the diagonal. This is 45 degrees. This is 15 degrees. Okay? 15 degrees. AGD here, AGD here. This angle, okay, which is the exterior angle. This is 90 degrees. Therefore, 90 degrees plus 15 degrees, 105. There's no need for you to find every angle. Some angles which is not necessary. You don't have to find this and this, okay? But many students find as many angles as possible. It's a waste of time, okay? And rhombus is a parallelogram, but four sides are equal. What else is the diagonal? Bisect each interior angles. These two angles are equal, and these two angles are equal, okay? And then perpendicular to each other. We have another midpoint theorem. You know that midpoints, you have to emphasize midpoints. Emphasize midpoints, you have to emphasize this. And then this is the midpoint theorem. The conclusion is these two lines are parallel to each other, and the length of the longer side, half of the longer side is equals to the length of the shorter side. Okay, this is the midpoint theorem. We see some simple examples. As I know that this is the midpoint. Okay, midpoints. Okay, so y is 24, midpoint theorem. This angle is 36. Okay, this is not midpoint theorem. You may say that it is corresponding angles, but why? Because they are parallel. So you have to show that these two lines are parallel to each other. First by midpoint theorem, then you can use corresponding angles, because if it is not parallel, you cannot write this. Okay. And the last is intersect theorem. Okay. Intersect theorem said that if these three lines are parallel, these two are equal in length, and these two are also equal in length. And another form of midpoint theorem, which is in the form of triangle, you see that these two lines, only two lines are parallel, but this is in the form of triangle. So this is also equal. This is intersect theorem. It is different from midpoint theorem. Don't get mixed up it. And we see an example. Find x, y, z. Okay. How to find it out? You don't know, but you know that this one is 4, and this one should be 4. Okay, therefore x is 4. Why? Intersect theorem. You have to write these parallel and equal, and then by intersect theorem, you find it 4. Okay? Pythagoras theorem, you can find it 5, and then by midpoint theorem, this is 10. Okay, not intersect theorem. This is midpoint theorem. Okay? You have to mention it, okay, so that you can use it as midpoint theorem. That's all for chapter 4.